In this video, I'm going to show you an interesting experiment that has a balloon blown up in a plastic bottle. For this experiment, the balloon is put into the hole in the bottle and the neck of the balloon is meant to be stretched out over the mouth of the bottle. Then the balloon should be blown up. But if you just do it like this and try to blow up the balloon will not actually blow up. So what we need to do is actually to somehow poke a hole into the bottom of the plastic bottle. And to do this, I think the easiest way is actually to heat up a screwdriver and poke into the plastic bottle. The hot screwdriver will melt a hole into the plastic. So now I'm going to screw the lid on the plastic bottle, and then I am going to heat up the screwdriver on at the stove, and then poke a hole into the bottom of the plastic bottle on the side. I think when melting a hole into a piece of plastic, the plastic will emit fumes. So I have a window open in here and I have the exhaust fan turned on. So now I'm going to turn on the gas and heat up the screwdriver. Okay, now the screwdriver should be nice and hot, and I'm going to melt a hole into the plastic. Maybe I need the screwdriver to be even hotter. I don't think this way of melting a hole into the side of the plastic bottle is possible. So I'm going to first use a needle to poke a small hole into the plastic bottle and then enlarge the hole with a screwdriver. Okay, that actually worked. Okay, so now we have a hole in the bottom of the bottle, and we are going to thread the balloon into the bottle and stretch the neck of the balloon onto the mouth of the bottle. So now I have the neck of the balloon stretched over the mouth of the bottle, and I should be able to blow up the balloon. So what should happen here is that the balloon would blow up in the bottle, and then when I hold my finger on the hole, the balloon should stay blown up. But when I blow up the balloon and put my finger here, the whole bottle just collapsed quickly. So this means that we need a stronger bottle that would not collapse. I don't think we can use a glass bottle because it would be difficult to drill a hole into the glass bottle. So I looked around the room and found this mouthwash bottle. This bottle is also made out of plastic, but it looks and feels stronger than this plastic bottle. I think with this bottle, the top, the bottom, and the sides are reinforced, but this bottle is also narrower between the two sides, so I think maybe the balloon would get squished while it is blown up. Let's still try this with the balloon and see what happens. Okay, so I poked a hole into the side of this bottle, similar to how I poked the hole into the other bottle, and let's see what happens if I blow up this balloon in this bottle, and then when it's blown up, I put my finger on the hole. Okay, so what has happened here is that the bottle still collapsed a little bit, but you can see that the balloon is actually still blown up a little bit. I have my finger still on the hole, so air cannot get into the hole. When I release my finger, the balloon deflates again. Okay, this time I inflated the balloon a little bit more, and you can see that the bottle has still been squashed a little bit. Now let's talk about what is happening here. So usually when we blow up a balloon, there is a higher pressure. The air is at a higher pressure inside the balloon than on the outside of the balloon. This is because the material of the balloon wants to shrink back to its original shape and squeezes the air. The air pressure on the inside of the balloon keeps it from collapsing and returning to its original shape. In this case, the air is still at a higher pressure inside the balloon than on the outside of the balloon, but in a different way. This time, the air inside of the bottle is at atmospheric pressure, but the air on the outside of the balloon in this bottle is just slightly below atmospheric pressure. So because there is more pressure on the inside of the balloon, it keeps itself blown up. Okay, I'm going to release the pressure, release my finger from the hole, and then there can be enough air to fill in this space, and this allows enough air pressure to push the balloon back to its original shape. In other words, when I have the balloon blown up and my finger on the hole, air cannot get into this part of the bottle to push to displace the space where the balloon is. The other thing is that the balloon didn't blow very big because the balloon is actually squished between the two sides of the bottle. I am still going to try to blow the balloon as big as I can in here, just to see what happens. This is about just the largest the bottle can blow up in here because the balloon is squished by the sides of the bottle. Okay, so that's another experiment that you can probably try. So that's it for this video, and I will talk to you next time.